service implementation that lives in the users module, because this is now a separate application. And this means that we will have to provide our own implementation of the permission service and somehow implement communication with the users module. So let's see how we're going to solve this next step that's going to allow us to support authorization in a microservices environment. I'm going to add an authorization folder in the ticketing module infrastructure project. Inside of it, I'm going to add a new class, which is going to be my permission service. Let's go ahead and make this an internal and sealed class, and it has to implement the iPermission service abstraction, which is available in the common application project. If we take a look at where this method is called, you will see that this is inside of the custom claims transformation. And this is going to extract the identity ID of the currently authenticated user from the available claims, and then it's going to pass it to this method that's going to get the user identifier and the permissions for the current user. Now, when we were still inside of a monolith, and let me go into that implementation, we could just send the get user permissions query in the users module and get back the response. However, in the case of the ticketing module, we can't send a query like that. So we have to implement communication to the users module, which now lives in a separate application, and we have a few choices in how we could implement this communication. One approach is sending an HTTP request to the Evently API instance, and we would need to expose an endpoint that's going to allow us to access the user ID and the permissions for the currently authenticated user. Given that we would already have the access token, this should be straightforward to implement, but we would also need to write a lot more code. An alternative implementation could be to use messaging and the request response messaging pattern that mass transit supports out of the box to implement this communication. So let me show you how we are going to implement this. I'm going to expose a request object in the integration events project of the users module. Let's introduce a new type inside, and I'm going to call it the get user permissions request. This can be a public sealed record, and all I need on this record is a string property called identity ID. Then what I can do from the permission service in the ticketing module is to inject an iRequest client from mass transit, and I can specify what is the request message that I'm sending, and this can be the get user permissions request. We are already referencing the users integration events project, so we can access this file, and let's call this the request client. And now I can go ahead and implement the get user permissions method. Let's start by creating our request object. So I'm going to say new get user permissions request, and we can pass in the identity ID, which we already have. Then I can use the request client that we injected as a dependency and call the get response method. Here I need to specify what is the response that I'm expecting to get back. And this should be the permission response that we have defined in the common project. I'm also going to specify an error in case something goes wrong. And this is an interesting implementation detail of the mass transit request response approach. You are allowed to receive more than one result type in the response. So here I can just send this request object and introduce a variable that's going to hold my response. So the response type is going to be a response of either a permission response or an error. And then I can call a helper method on the response type, which is the is method, and I can use the out parameter to define the response that I'm expecting to get back. So let's say if this is a response containing an error, then I'm going to call this the error response, and in that case I need to return a respective error from this method. So I can say return result failure, I can specify permission response, and then I can access the error response message and pass this in to the failure method. Otherwise, I can check if this is a response containing the permission response. So I can say if response is out and then response and specify permission response. And let's call this the permission response variable. In this case, we can just return the permission response message. If we don't match on either of these two response types, then we have some unknown failure, and I'm just going to return a static not found error that I'm going to define here. So I'm going to say result failure, permission response, and pass in the not found error. So this is the permission service implementation in the ticketing module that we will need to also register with dependency injection, and we're going to do this in a moment, but let's consider a few more technical details. First of all, I want to explain how the communication using a request client works. This is going to send the request message using mass transit over RabbitMQ. Then we need to define a respective consumer that knows how to handle this message and return back the permission response. So we need to create a consumer in the users module, handle this request, and return back a respective response. So let's go ahead and introduce that handler in the users presentation project. And I'm going to add a new class in the users folder, and I will call it getUserPermissionsRequest consumer. This will have to be a public and sealed type, and I will need to implement the iConsumer interface from Mass Transit. Then I can specify the getUserPermissionsRequest, and let's go ahead and implement this interface. So here we want to access the context, which gives us the getUserPermissionRequest, and then we can access the identity ID. So the simplest approach would be to either send the same query as in the permission service, or I can inject the iPermissionService implementation and use that to return back the respective response. So let's make this asynchronous, and then I'm going to say await permission service getUserPermissions async and pass in the identity ID. Let's capture this inside of a variable, and I'm going to call it just a result. And then if this is a success result, we're going to send one message back by saying context respond async, and I can just specify the result value as the response that I want to send back. Of course, I need to await this. Otherwise, let's go ahead and say await context respond async, and I can pass in the result error. So this is either going to respond with the permissions response if this is a successful result, or it's going to respond with an error if it's a failure result. So you can see the implementation is very straightforward inside of our users module. We will also need to register this consumer with Mass Transit. So let's go to the users module definition, and I'm going to add a code snippet here that's going to configure my consumer. I'm also passing in the instance ID so that I can set this value on the respective endpoint. And then we need to call this from the program file of the Evently API project. So let's close this down, and I will open up the Evently API. And here, where I'm configuring the other modules in the system, let's also pass in users module and the configure consumers method. This takes care of consuming the getUserPermissionRequest and returning back the permission response from the users module, which is going to run in a separate service from the ticketing module. Because this is going to require request-response communication on every API request to the ticketing module, it really makes sense to introduce caching inside of this module to make this operation faster. So let's inject the iCache service inside of the permission service, and let's add a simple implementation of the cache aside pattern. I'm first going to paste a code snippet that's going to help me to create a respective cache key for this identity ID. And because I'm using Redis behind the scenes, I can just as easily introduce caching in the other permission service implementation using this same cache key value. And as I said, because we are using Redis, this cache key can be shared in a distributed system. Now, what I'm going to do here is say await cache service, and let's call getAsync and specify the permission response. Then I need to say create cache key and pass in the identity ID, and we should get back a permission response, which could be null. So I'm going to say if permission response is not null, in that case, just return the cached value. Otherwise, we have a cache miss, and we are going to send the request to the users module, and then I can set the respective value in the cache after I get the permission response. So I'm going to say set async, and I need to pass in my cache key. So let's create that. Then I need to pass in the value that we are caching, which is going to be the permission response message. I'm also going to create a local cache expiration time span. And let's say that the expiration is 5 minutes. And this should be enough for a simple implementation of the cache aside pattern. So we are either going to return this value from the cache or request it from the users module and then cache it for subsequent requests. And now we need to register this service inside of the ticketing module. So let's open up the ticketing module, and for example, right at the bottom here, I'm going to say services, add scoped, and specify iPermissionService and the respective permission service implementation in the ticketing module. I'm also noting that we don't need to configure anything to be able to inject a request client. Mass Transit can automatically provide an instance of this service. So let's go ahead and close down these files. And the only thing that remains now is configuring our reverse proxy to route requests to the ticketing API service. So let's also close down the program file and navigate to the event